Hello, my name is Edward Wustenhoff. I'm CTO and co-founder of Burstorm, and in this segment I'd like to talk about the Burstorm performance benchmark and how it manifests itself in the application. As you can see in this diagram, the Burstorm application addresses many aspects necessary to enable the cloud ecosystems. We look at the provider side, products, etc., etc. And we look at the consumer side, enabling architects to design new and remodel existing environments. It is in the product area that the performance benchmarking plays the most. As you might recall from other presentations, the Burstorm Common Specification Language defines products around and in the context of economics, performance, security, availability, and change. The Burstorm Performance Benchmark is the first step in an ongoing process to describe more and better information around the performance aspects of cloud services. When I first started thinking about the challenges that might come with benchmarking performance in the cloud, I started talking with my friend Eugene Eng, associate professor at Rice University in the computer sciences department. And we started talking about the effects of being less in control over the underlying layers that might affect performance. And not only that, when you look around in the cloud environment, you see thousands and thousands of different products, and they all have different performance specifications. They also reside in different locations, and in many cases, the implementation of the same product, let's say an M3 extra large, might not be implemented the same way in Europe as it is in the US or in Asia Pacific. And then on top of that, not only is the performance important, but if you associate the hourly consumption with things like performance, then the different pricing models also become quite a challenge. How do you assign a price performance number if there's so many different ways you can pay for it? The flexibility and the velocity of change in the environment is huge. There's new products every month. And then the prices changes. It's a very dynamic marketplace. And then on top of that, there are continual infrastructure updates and changes, and we have some great examples of that later on. All in all, it's a massive problem to create a succinct and understandable view of the impact of all this to the ability to execute instructions on these cloud services. The result of all these discussions find themselves in the Rice-Burstorm Computing Performance Benchmark. And in essence, we try to measure all instances everywhere all the time in order to address all the challenges that come with performance in the cloud. So what does that mean, measuring all instances all the time everywhere? And why did we end up on that? Well, because of the continued change and the many different ways the cloud servers are implemented, there is really no other choice than having to look at each instance specifically in a specific moment in time, because when you spin these things up, you might be impacted by busy neighbors. And then on top of that, you have to do it everywhere, meaning, in the 3 different continents, in different locations, to be sure that you get the performance that you would expect out of a particular system. The other part is that it's not a one-time job. You have to continue to work with the community to not only improve the test. The first phase, we were not focused on the actual test. We just wanted to see how things are different if you run a simple test everywhere all the time on all instances. But over time, yes, I/O, network, and memory is an important shared resource, and we want to understand how this gets impacted by all the dynamics that play in this field and over time. So we will be working, and you'll hear more about different and expanded tests in this particular area. So what does this really mean in the execution of the performance test? So first of all, it is economically not feasible to run instances all the time everywhere. but we can emulate it pretty good. So what we do at Burstorm, we actually spin up all instances of the top 6 providers, so SoftLayer, AWS, Google, Rackspace, etc., and a couple of more others, and we're adding names as we go, and we spin them up at a random time 3 times a week, and we execute our performance tests. These tests get run on the instances, and when they're done, they write their data to the Burstorm application database, where it gets combined with the economic data that we have. And out of that comes some very interesting reports. In May, when we kicked this off, we created a one-time report just to illustrate the interesting things we found out. But the real power is that it continually changes, and therefore we have actually an interactive view in the app where you can look what is the state of the performance in the cloud today. In the next couple of slides, I'll give you some examples of interesting findings that you will see when you do this kind of work. So what you're looking at here is the 4 core systems of 3 top providers put next to each other. And at first glance you can see that an AWS instance is the clear performance winner. But then if you look not only at performance but also what it costs to buy that performance, which is the graph underneath it, things shift quite dramatically. And if you look carefully, the Linode instance actually is the most cost effective. So this means if I could spread my performance requirements, my workload, over multiple systems, then Linode is actually more cost effective to run the same load over multiple systems as opposed to trying to run it all in one system out there. So quite interesting to see what happens when you combine performance with economic impact. What you see here is the performance over time of 3 Google 4 core instances. The first thing you might notice, the big jump around May. This is actually when Google made an infrastructure update, and where the performance was about 30% lower in the beginning. You see this big jump coming up in May. This is a great example why you want to look at this over time, since stuff obviously changes as time goes by. You also see that for the 3 different systems, the performance is about the same. This comes because the tests that we're running to date are fairly CPU-centric, and you can see the differentiation is about high memory and high CPU and standard. So let's take a closer look what happened if I introduce some economics to it. So as you can see, when you look at price performance over time, you see the 3 different 4 core systems separate each other a little bit. And this is because the price of these systems is differently. So if your workload is CPU-centric, you should actually go to the one that gives you the best price performance for that particular run. Another interesting example of performance over time is what happened to Linode. In about June-July timeframe, they actually migrated from a Zen virtualization to a KVM virtualization, and you can see this massive jump in performance. And they actually made quite a big marketing campaign out of it, and rightfully so. I mean, it's almost a 3 times better, 300% better performance due to an infrastructure update they made over time. The other interesting thing, though, is that you see it taper off a little bit as time moves forward. And we suspect that becomes as more and more people are moving to this KVM-based infrastructure. And so you see a little bit of the early days where the infrastructure is not that heavily used, and you see some impact as usage of the infrastructure increases over time. So now let me give you some examples of the impact of infrastructure and location. So what you're looking at here is an Amazon and Google instance type, and they are reported by CPU type. So what you can see is that Amazon instances actually use the same CPU, and if you can see here with the Google side, you see the little blue dip on top of it, that's the performance for a different CPU type. The interesting thing is, as a lot of us might know, is that gigahertzes, the speed of a CPU is not necessarily better. It's actually proven here. The 2.3 gigahertz CPUs have a higher performance than the 2.6 gigahertz. But you can see there is an impact. There are different physical implementations for the same instance type, depending on where and who runs it for you. A slightly more dramatic example you can find within Microsoft Azure. They have several different CPU types that deliver the same type of instance, even to the extent that they use AMD chips and Intel chips intermixed. And there's definitely workloads out there that are sensitive to the chip architecture that runs the execution. So this is important information that you find out when you start collecting performance data in an application like Burstorm. Last but not least, let me give you an example how location affects the performance of particular instances. What you see here is that the Google performance numbers of the same instances in different locations show different results, where quite consistently the European test results are better than the US ones, and the US ones are better than Asia Pac. On the other end, you can see that AWS's performance is consistent across different locations. We attribute that to the fact that it seems they deploy the same stack for a particular instance type everywhere in the same fashion, which obviously should yield same performance results. So what is next? Well, obviously we're going to continue doing what we're doing and adding more data points over time, executing the existing benchmark tests. Obviously next on the roadmap is the development of what we call RBB, where we expand the tests with additional memory and network components. Also a little bit more focus on better I/O tests, especially since SSD and large CPU caches has impacted some of the performance results. And then last but not least, we'll be including more tests around looking at different types of storage, archive versus SSD versus network attached. As mentioned, we'll be adding more and new service providers. And then last but not least, a multi-system infrastructure test. This is obviously a very complex matter, but we see in environments like Hadoop that are very well defined as to what components are part of it, and also have very well defined and somewhat unique workloads that can run through it. So those are the new things that you should be looking for. And last but not least, in January we'll be announcing that you can add your own private instance tests to compare. So this will enable enterprises to run tests on their own, for example bare metal infrastructure, and see how that compares to what we know about the cloud ecosystem. Thank you for watching this video. I hope you are as excited as we are about what is happening with the performance benchmarking at Burstorm. But if you want some more information, please go to our website, www.burstorm.com, where you find more videos and other materials. Or if you have direct questions, send an email to info@burstorm.com or call us on the number provided on this slide. Thank you.